Alright guys, we've made it to the last video of Trig Chapter 1. Let's do a shout out to Alina, Scott, Ronnie, and Parker. You guys get the last video of this chapter. If I didn't get to you guys, you can maybe have some shout outs next chapter for other people. This one's kind of fun because it's kind of a review from last chapter. Or not last chapter, last year in geometry. It's basically SOHCAHTOA right triangle problems. All angles should be measured given to the nearest minute, and length should be to the nearest tenth. Make sure you're following the directions on that. Key to these problems, draw the picture correctly and make sure all the values are in the correct place. So we have a house, a ladder leaning against a house. Here's my house. And you can have fun with this and, draw things on your paper. And here's the ladder. Let's say it's touching here. This is the ladder, the red, I should say that red line is the ladder. And this is the grass it's on. Okay. So it says a ladder leaning against a house makes a 60-degree angle with the ground. So 60 degrees. The base of the ladder is 7 feet from the base of the house. Base means bottom. So the base of the ladder and the base of the house, the distance between those is 7 feet. How long is the ladder? Well, there's two ways to do this one. This is a special right triangle one. So you could actually use special right triangles if you remember your pattern. Or we'll just do SOHCAHTOA. We're looking for the ladder length. That would be the hypotenuse. So remember, SOHCAHTOA, we have the adjacent side, we want the hypotenuse. So we're going to use cosine for this problem. We have adjacent, we want hypotenuse. Remember, whenever you set these problems up, you just start with the trig function. Cosine of the angle, which happens to be 60 in this case, equals the adjacent over the hypotenuse. I'm going to put that over 1 so I can cross multiply and solve. When you cross multiply, you get x is equal to 7 over the cosine of 60. Do not divide the 7 and the 60. This is one number. And you get x is equal to 14.0 feet, which makes sense because if it was a special right triangle, this is across from the 30, which is your x value, and this would be double it, 2x, which is 14. Alright, so that's the first one. 14 feet. 14.0 feet. Alright, an airplane rises vertically 1,000 feet over a horizontal distance of 1 mile. What is the angle of elevation of the airplane's path? Now, vertically means straight up, horizontally means straight over. So, here is my runway. There's the vertical distance, the horizontal distance, there's the vertical distance. Let's try to draw the plane. And then there's a wing. I think that's pretty good. Or it's a dinosaur. I don't know. It's a flying something. Alright. So, that is the plane. It says it rises 1,000 feet vertically. So that's all that is right there. You do not put it here because the hypotenuse is not vertical or horizontal. It's a combination of both. Whenever it says vertically, it's there. Horizontally is down here. But it says 1 mile. Would it make sense to put a 1 there? What do you guys think? Hopefully you said no, it doesn't make sense because, Mr. Franek, 1 mile and 1,000 feet are in different units. So we have to convert this. 1 mile turns into 5,280 feet. That is something you should know. And we're looking for the angle of elevation. I'll call it theta because you guys are getting used to it. Or x, whatever you want to call it. Okay. So SOHCAHTOA, I have opposite, I have adjacent, I want the angle. Opposite and adjacent, the x and the y is tangent. So tangent of the angle is equal to 1,000 over 5,280. To solve these, we just did these a lesson or two ago. To find an angle, you use inverse tangent. Make sure you're in degree mode because it's said to the nearest minute. And make sure to change that. So this is what you're entering in your calculator. And you should get a theta of about 10 degrees and 43 minutes. Okay? which makes sense because it should be a small angle. It only rose a little bit, but went a full mile before going only 1,000 feet. So a ranger is on the top of a lookout tower. Okay, so here's my tower. Let's just pretend that the ranger is standing in the tower, but there's the head of the ranger, and looks down. Well, first of all, the tower is 200 feet above the plane, so let's do that. Spots a fire at an angle of 3 degrees from the thing. Okay, fire. So we need a fire. Now, fires are red and orange. There's the fire. Now let's put some yellow in. And if it's really hot, hopefully you guys learned this, a blue flame actually is really bad. So, there's my triangle. And it's they say that it's 200 feet above the plane. Spots fire at an angle of depression. Remember, angle of depressions always and angles of elevation are always measured from the horizontal. So this is 3 degrees, not the angle here. And if this is 3 degrees, and these are parallel lines, the angle of depression actually ends up being the same thing as the angle of elevation. So we're going to put the 3 there. Again, the 3 does not go from the vertical. Depression and elevation are the same thing. It just depends on if you're looking down or up. So it says, what is the straight line distance from her to the fire? Well, straight line distance, that would be, I'll call that x. That would be this part. Okay? From her to the fire, that's the hypotenuse. It also says how far from the base is the fire. So I'll call that y. We'll do another problem for that. And that would be for this part of the problem. Basically, you're just doing 2 trig problems. So, for the x, we have opposite, we want hypotenuse. So that would be sine, because we have y in hypotenuse. So sine of 3 is equal to opposite over hypotenuse. Cross multiply. And type into your calculator 200 over sine of 3. And make sure you're in degree mode again. And you should get an x distance of 3,821.5 feet. Okay. Now, how far is the fire from the base of the fire, or from the base of the tower? Let's do another one. Again, here's the other thing. Some of you guys might be like, "Oh, I want to use the hypotenuse now." Don't use this number because it's already rounded. Use the 200. That's a set value. So we're going to use the y and the 200. So I have opposite and adjacent. So for y, I'm going to use tangent. And it's going to be 200 over y. So when you go about changing these around, you get y is equal to 200 over the tangent of 3. Which comes out to be 3,816.2 feet. And that makes sense. If it's a 3 degree angle, that's barely anything. So that means that if it's a 200 rise, to be at a 3 degree incline, this will be very long, and this will be very close to that. Of course, this should be bigger, though, because it's the hypotenuse. So those are 2 values. All right, we got 2 more. These are a little more complex. Greg is standing on a balcony of his hotel room in Wisconsin Dells that faces the water park. So we have a hotel. So here's the hotel. Here's the balcony. And here's Greg. We'll just pretend he's here. Let's pretend his eye is here. It doesn't matter. There's a water park over here. And there's a slide. So there's a slide going like, well, let's not make the slide blue because the water will be blue. The slide going down. Okay, there we go. And into water. Splash. Okay, so it says the tallest slide in the park is only 124 feet from his balcony. So that means a horizontal distance. So here he is. This distance is 124 feet. It says he looks down at an angle of depression at the base of 31 degrees. Okay. And again, that's this angle here. Or if you want to draw the triangle like this, if you want to do this instead, that's fine as well. You can draw the angle. So this is the angle here, 31, which can go here. And again, we know that this is 124 because that's what it gives us from the water slide to where he is horizontally. He looks up at the top with an angle of 27 and still a 124. How tall is this slide? Well, basically this is a two triangle problem. You can do either triangle here. I drew this other one, you didn't really need it. I was just showing you could if you wanted to. So we want this length here. I'm going to call this one X and this one Y. And you have two problems. So we have opposite and adjacent because we have this 124 for both triangles. So I have tangent of 27 is equal to X over 124. Okay? When you cross multiply, you get 124 tangent of 27. So you get is X, which is 63.2 feet. Now we need to find Y. We still have opposite. We want adjacent. We want opposite. We have adjacent. And so we will do tangent of 31 this time is equal to Y over 124. So you get Y is equal to 124 times the tangent of 31, and you get that Y is approximately 74.5 feet. So all you have to do to find the total height of the slide is add both numbers up. So 63.2 plus 74.5. So the total height is 137.7 feet. That's how tall the slide is. Alright, last one. Jamie is watching her friend Julie go for a hot air balloon ride, standing 130 feet from where the balloon launched. So, here's Jamie. Again, we're not assuming that Jamie is any feet tall. We're just going to pretend that she's at ground level. 130 feet, and then there's a hot air balloon. And then there's a basket that, okay, whatever. That it probably doesn't, should probably be a lot bigger. Okay. All right. So it says she's 130 feet from where it is, so that's this. Jamie looks up at Julie at an angle of 28 elevation of 28 degrees. So actually, the balloon has already launched, so I probably should have drawn it over here, but that's all right. So here's looking at the balloon, 28 degrees. Then there's something later. So we can either do it on the same triangle or on a separate one. I'll show you what it looks like on the same one. 5 seconds later, she looks up at an angle of 51. Well, 5 seconds later, the balloon's up here. And she looks up there. Oh, that was a bad line. And now this big angle's 51. So you have two separate things. If you want to redraw that one just to look, you have this 51 and 130, and then you have the 28 and the 130. How do you find how far she rose? Hopefully you guys see that the distance we want for this problem is that distance. That's how far she went in 5 seconds. And in order to do that, you have to get the full distance minus her starting distance. So we have two problems. We have to just subtract. To get this height, I'll call the little one X, the big one Y. We have opposite adjacent. These are all tangents. So tangent of 28 is equal to X over 130. Multiply 130 times the tangent of 28. And you get, which is X, which is 69.1 feet. That's how tall the balloon is when she starts out. And we do the other one here. So we're going to do 130. Oh, I screwed that up though. Be careful. It is not 28 degrees anymore, is it? It is now 51 degrees. So it's tangent of 51. So 130 tangent of 51 equals Y. And when you multiply those out, you get that the balloon is now at a total height of 160.5 feet. So to find how far it rose by, you have to do 160 minus 69.1. So 160.5 minus 69.1, and you should get that it rose 91.4 feet. So the balloon rose 91.4 feet. That's pretty fast, actually, in 5 seconds. So that's how you use SOHCAHTOA to find missing pieces of triangles and word problems. Your classwork will be worksheet 8. That's the last thing that'll be on the test. So pretty much the test is the first 2 quizzes plus a couple problems from here. Alright, I will see you later.